Hello again, community members, users, and guests. Welcome back to our EdgeX Adopter series presented through our Vertical Solution Group. As always, my thanks to Henry Lau from HP for all the logistic heavy lifting, and for Camilo, Andy, May, and the marketing team for getting the message out about these and other events. Deeply appreciate everybody. Great set of meetings we've had this summer. So today, Tibco will present on their use of EdgeX Foundry, specifically in Project AIR. Tibco, for those unaware, is a big data and business integration solution company based in Palo Alto, California, offering products like Tibco Enterprise Message Service, which for those of us in the Java world have been using in messaging and EAI solutions for years. We're honored to have with us today Jesús Centeno and Marcelo Gallardo. I hope I didn't butcher the names, guys. Jesús is head product evangelist from Tibco's Office of the CTO. Jesús drives adoption of Tibco's strategic new and emerging products and technologies, of which Project AIR and Edge Solutions are a part. Prior to joining Tibco last year, he was in charge of global alliances and partnerships and served as a solutions architect while at Clix, a cloud data integration and data analytics solution provider for nearly 8 years. Also with us today from Tibco is Marcelo Gallardo. Marcelo is the Senior Solutions Architect at Tibco's Office of the CTO. He has been for Tibco with, please get this everybody, 30 years, if I've got that correct, Marcelo. I don't think there's anything that I've owned for 30 years, so that's well done.
It's 20 only, sorry. It's only 20, sorry.
Oh, only 20, or even that, still a considerable amount of time, so fantastic. And he served there in various architect roles. Project AIR, as we'll learn, is a solution that, quote, enables a centralized access and management of IoT devices, efficient processing and storage of IoT-derived data, and support for running analytics both at the edge and in the cloud, unquote, which I think should sound familiar to all of us at EdgeX. So please join me in welcoming Jesús and Marcelo. Gentlemen, I'll let Henry pull down this slide and let you take it away.
Yeah, go for it.
Excellent. Thank you so much, Henry, Jim. Very excited to be here with all of you today. And hopefully, if you can just confirm that you can see my screen, that'd be great.
We can.
Yeah, looks good.
Excellent. Yeah, so I guess just to put a face to the names, that's us, Jesús, and my partner here, Marcelo, principal architect of Project AIR that we're going to be talking about today. And just a quick confidentiality agreement commercial. And, you know, as Jim mentioned, you know, we are part of Tibco, and in the next few slides, what I'll try to do is to give you a zoom in from, you know, we're going to start with a 10,000-foot view of, you know, Tibco, and then we're going to zoom in all the way into the project. So for those of you that don't know anything about Tibco, and if you start reading about Tibco, you would see, you know, how we basically, all the solutions that we have, you know, they go through these three main themes: connect, unify, and predict. You know, Project AIR is a great example on how we achieve that with Tibco's technology and a combo between our technology and open source technologies. We go from open architecture to basically unifying all the data, bringing all the data together. And once you have all the data together, whether it's through data virtualization or some other methodology, then you can apply things like analytics, machine learning, you know, a combo of many different subject areas to get the insights and the value out of the data. So, you know, also we mentioned that Project AIR is part of an umbrella and Tibco that is called Tibco Labs. So just really quickly, so you understand where we're coming from, Marcelo and I, we are part of this group. Tibco Labs is an innovation program at Tibco that it basically is designed to jointly discover with partners and customers and really help organizations to understand how they can incorporate that innovation aspect, leveraging open source technologies, leveraging Tibco technologies in many different areas, right? Things like AI, ML, IoT, of course, that we're going to be talking about today. But not just that, like AR, for example, NLP. So if you know, as you start reading more or learning more about Tibco and Tibco Labs specifically, you'll see that we have different projects, Project AIR being one of those projects, and that's what we're going to be zooming in today. But if you want to learn more about any of the other areas, feel free to contact us after this session as well. We'll be happy to talk to you. So, taking now kind of like a deeper zoom into then IoT and Tibco, right? So, Tibco has a long history of doing IoT. So, what we're going to be talking about today is definitely not something new to Tibco. We've been doing this for years and years. We have like very interesting stories. One of my favorite ones for sure is Formula One, what we do with the Mercedes Petronas team. How they leverage, kind of like your plain vanilla classic IoT scenario, right? Like real time understanding what's going on, with the car, with the pilot every time that the car is out there on the racetrack. Accumulating huge amount of data and then just getting insights real time to make adjustments, right? And then get that marginal advantage. In many cases, these scenarios are, whether if you get like a 1 second advantage over your next competitor, that's the difference between winning and losing, right? So that's what we do. So Project Air basically is an encapsulation of all that know-how, right? So for us it was a matter of like how we package these in a way that it's easy for organizations to do IoT with Tibco. So Project Air allows you to do the registration and interaction with your IoT edge side of the house. And not just that, but like more importantly, really just to process the IoT data, and in the concept of what Marcelo will be explaining in more detail, like data pipelines, right? So just making sure that the data flows from your IoT edge into the rest of the enterprise and back and forth, right? So bringing things to the edge as well, right? So not just consuming, but also pushing things like analytics at the edge or ML at the edge, right? And I think there's a little bit of feedback on the line. So if you wouldn't mind, please mute yourself. Thank you so much. So, just basically processing that data and then pushing some of those capabilities back to the edge as well. We follow an agnostic approach. So, we'll be talking a little bit more about what that exactly means in just a second here. And, for our customers, something that is really big is the ability to own the data, right? We just don't provide only the capability to access your IoT edge side of a house and connect that to the enterprise, but also, keep ownership on the data, right? So if you want to then leverage the data for historical analysis or incorporate that data with anything else going on in your enterprise, right? As I mentioned at the beginning, that unify concept, you can easily do that with Project Air as well. And the project was designed in a way that is extensible in any direction, in any layer, right? So whether it's on the devices, on the endpoints, on the data sources, you can easily expand in any direction as needed. So you can grow basically with the organization. So when we explain Project Air, probably the easiest way to explain it, right, is this slide, right? Like you have the ability then to register, interact with devices, process the data. And when you put all that combined, then you can achieve very concrete, tangible business outcomes, right? Like automation, cost savings, reduction of risk, visibility, auditing, better customer engagement, real-time solutions, right? Like being able to interact with your customers in better and new ways. So if you think then, like if you walk away from this session, right, with this slide in your mind, right, like this will help you to articulate then, to your colleagues, for example, what Project Air actually does, right? Like what is that you can actually do with the project. So you can, as we mentioned, we can connect, extract, and you can do all the data management on the data. You can create triggers, basically, so you can then respond to the certain IoT events as the data comes into the project. You can funnel the data into the long-term repository. So basically data at rest, right? You can funnel the data in any direction in your enterprise. And then once you have the data through the project, you can visualize, explore the IoT data. You can, combine things with, the data with AI or ML, bring those capabilities to the edge, as I mentioned. And then you can have like all the monitoring capabilities on your basically end-to-end pipeline. So thinking then in terms of on the infrastructure side, when I said agnostic, this is exactly what we mean, right? You can deploy this in any cloud environment. You can leverage modern technologies on the edge at the cloud as well. And then you can extend the project, right? Whether it's basically incorporating more data points in your organization, incorporating more devices, or simply just incorporating different data stores into that data pipeline story that I mentioned. So as you can imagine, then, Project Care for us allows us to go very horizontal, allows us to address a number, very large number of use cases across many different industries. So whether, our customers are in manufacturing, healthcare, telco, logistics, transportation, or retail, or they have like a hybrid business model of some sort, for us, it's very easily to incorporate the architecture and provide value. As you can imagine, right? Like we have at the core EdgeX Foundry, so that's really it was a very strategic decision for us, mainly just to follow what we were seeing in the industry, right? And I think, as time goes by, for us it has been great to learn about like more and more organizations using EdgeX Foundry as well, in very similar fashions as we do. So that has been a great confirmation that we basically picked the right strategy. But for us, it's really the core of the project, right? It's the component that allows us to connect that IoT edge side of the house, right? Like all the devices with everything else that you have in your enterprise, whether it's on-premise, hybrid, or cloud. It really doesn't matter for us. So when you think in terms of, concretely, right, like what EdgeX then does for us, it allows us to have that IoT distributed architecture, specifically from the framework. And in just a second, we're going to jump into demo. So Marcelo will be highlighting these pieces as he goes along. But we leverage many parts of the framework, right? We leverage the ability to connect to many different type of devices. So for us, it's very important to come into a scenario, right, or a customer side, right, and be able to say, yes, we'll interact with, whatever you have on the IoT edge side of the environment. And also, as the data comes in, we leverage the ability to do the registration of the devices, understand the metadata that is coming, the metadata of the data, right, and understand the taxonomy of the data coming in, so then we can store it properly. And then also the ability to create rules, alerts, notifications, and then be able to integrate that with the rest of the flow. So if just, and I think this is the last slide that we have before we go into the demo, but just to give you an idea then how all this comes together for us. So we have, if you think of either your own organization or, if you work with different customers, right? Like you think of your customers' ecosystem, then you'll have the edge side of the house, right? And this can look 1,000 different ways, right? Whether it's, like a closed circuit, right? Like something like a factory where you have like sensors across the production line. The sensors may be talking to each other, but they have like no access to the outside world. Communicating via Bluetooth, for example, or you may have, sensors on containers in the middle of the Atlantic Ocean with just satellite connectivity, for example, right? Or things that they communicate over Wi-Fi, for example, right? Trucks moving across the country, right? So whatever the scenario it is, that collection of sensors, right, like will communicate to some sort of gateway, right? So the gateway could be, close to the, let's say, production line, right? Close to the sensors itself, or it could be in a remote location, right? Like this can also look in many different ways. But for us, it's very important to say, whatever this edge side of the house is going to look like, Project Care comes in and attaches to the gateway, right? So we have then now EdgeX running at the gateway level. So that's going to be our entry point for the project. We leverage other Tibco specific components. So for example, we use something called Tibco Flogo. Flogo is an open source, it's another open source project. So we have an enterprise offering on the project, and we use it as part of the architecture. So in combination with then the framework and Flogo, we do the device registration, the configuration. We through the interface, then the users can basically set the business rules that they want to use on a specific IoT event. They can define alerts based on those events, notifications, and we do that as you know, like leveraging standard protocols like Kafka and QTT. Now, from the project, then we have the ability to then stream data into whatever your enterprise looks like, right? So again, whether it's on-premise, hybrid, or 100% cloud. And typically this takes place in two different ways, right? Like the classic one is, you want to take that IoT data that you're streaming and then put it in some place at rest. But then, whether it's going to be your big data environment or something like Snowflake or something, you want to match the rest of your infrastructure with AWS, let's say, so you want to use Redshift or, whatever the case it is, you can do that from Project Air. If you have like 100% Tibco environment, you would be using something like Tibco GraphDB, for example, right, to do that storage. And then once you have the data rest, then you're going to do analytics. So for us, our customers typically do that with Spotfire and Tibco Data Science. And then they take all the insights into basically a web application to then give access to a wider set of users. So in the case of Tibco, we use something called Tibco Cloud Live Apps. So a very easy way to basically put together applications that leverage different sources and different insights from different components. And that opens up the door to a wider consumption of the IoT data. Now, the second flow that we typically see is more kind of like a real-time fashion, right? Where you have like that event processing coming from Project Air. In the case of Tibco, you can use something called Tibco Cloud Events to do that. That processing can be enriched real-time with analytics or not, or it can flow straight into the enterprise. And then you would have an API gateway basically to enable the access and the consumption of those events. So in the case of Tibco, you would use something called Tibco Measure to do that, where you can then have like that gateway giving access to that data and incorporate that data into your web applications. So you would use something called Tibco Cloud Integration to do that as well. Now, the more important thing is that, again, for us is regardless how the edge looks like and the enterprise looks like, for us, Project Air is that glue that basically brings the two worlds together. And a big differentiator for us, as opposed to what other players in our space do in IoT, is not, remember, it's not just the consumption, but it's basically the interactivity, right? Like being able to send things back to the IoT edge. So for Project Air, being able to respond real time with IoT commands back to the device, right? So if the device is too hot, right? Like the bulb is about to explode, right? Like you can send a command to say lower temperature or shut it down or something of that nature. So with that, let me pass the ball to Marcelo, that is going to walk us through a demo that it's going to explain all these in detail. Very, very cool demo. And as he sets up, just a quick commercial. If you want to learn more about Project Air, you can visit our page on Tibco Labs. And we have basically the project is posted on GitHub. There's a repository where you can download. It comes with some examples on how to get started easily, whether it's locally or on AWS. So make sure to check it out. All right. So Marcelo, let me stop sharing so you can share your screen.
Definitely. Just 1 minute. Okay. Can you guys see my screen?
Yes.
Okay. Hello, everybody. My name is Marcelo Gallardo. As was introduced, I've been at Tibco for 20 years. I'm currently working at the office of the CTO on some very exciting projects. What I am going to demo today is a subset of all the features that Jesús just went over. Basically, I will be showing some of the features that are open source. I won't be demoing some of the features that will require a Tibco license for, like, for example, integration with live apps, and also some of the cloud features that we provide under license. But all of these that I am going to show is pretty much in the open source license. Okay. So to get started, let me say that Jesús mentioned that we are using several features of EdgeX, and the main feature that we're using is the device API. We have created several device drivers and simulators for some of the data that we will be seeing here. And also we are heavily using the applications SDK. So some of the components that we are using to create this demo are following the same principle that EdgeX uses. Everything is containerized and is deployed either to the edge, and also we deploy the cloud components as containers and are deployed to, right now in this demo, all the components are deployed to Kubernetes cluster running in AWS. Okay, so let's get started. When we get started, when we first get into the system, we get a screen that will give us a summary of all the different devices or device groups that we are monitoring, that we are managing. So here we can see that we have two device groups. One is electrical vehicle devices. If I click it, we can see some of the details, the location, the address that we can communicate, and also we have here a map that will show us the location of this group of devices. As you guys can see, this group of devices is running in Seattle in AWS warehouse. That's where I am running this group of devices. And the other group is the electric plant simulator, and that is located in Florida. That is in my house, and I am running those devices here for the demo. So I will be showing you how to interact with, as you can see, devices in very far locations from each other. So here, for example, I can ping the devices and can see that I am successful, so the connection is good. I can jump into my other group of devices and also ping the devices, and I can get a response successfully, so I am good to that. So the first concept that I want to introduce to you guys is the concept of data pipelines. So what we have done is that we are creating these pipelines either at the edge or at the cloud, and it allows us to configure what to do with the data that's coming from the devices. So in this case, I will quickly show you how we will configure these pipelines on the cloud. So the first point we need to go is we have a tab will show us the endpoint configurations. These are automatically configured right now. I don't have, oh, sorry. I selected the wrong gateway I want to work with that I have configured already. So I have configured this electric. Okay, so for this gateway, I have configured, I am going to be receiving data through an MQTT broker. And here you guys can see the configuration. You can review it, and you can add extra protocols if you desire. So right now we support MQTT and Kafka. We also support Tibco Cloud Messaging, is a proprietary messaging protocol. And also we are going to support some other protocols in the future. Also here in this page, you can configure different data stores where you want to save your data. So in this case, I have pre-configured a Postgres database. Again, so here you just enter the information, how do you want to connect to that database. And again, we support several databases like Snowflake, Oracle, MySQL, Tibco GraphDB, dgraph, and a few others. So you can all of that configure before you start creating your pipelines. So let's go back to the gateways and select this electric plant, and let's create some gateways here. So if I go, some pipelines. So here on the pipelines, we have created an interface that allows to dynamically create how you want to manage your data. Again, this is nothing that is running right now. All the things that I am going to do is I will configure, and at the end of the configuration, I will send out the configuration to Kubernetes cluster where we will create a container and will be deployed dynamically at runtime. So right now we don't have this container running. I am going to configure how I want to do it. So here, first thing, you select the type of data that you want to treat. In this case, we have two types of data. It's the device data, and also we can do something different with notifications. So for this demo, we just concentrate on the device data. I'll click next, and the next step is to select the protocol, how your data is being received here. In this case, we have selected to use an MQTT broker, so I select the MQTT. I am shown the details on my broker, and if everything is okay, I can continue next. Next, we can filter the data. So here, imagine you have many devices, so you might not want to consume all the data from those devices. In this case, I just have one device that's called power plant. So I don't want to filter it, so I'll just skip this. But if I want to filter this data, I will just select, and the data will be filtered. Next, here we can configure how if we want to stream the data. So for example, here I can select a device. In this case, there's only one device, and then select the different instruments that that device has. These are the sensors. And then you can select like what function you want to apply, like average, sum, min, max, count, or whatever operation you want to do for aggregating. And also you can select the different type of windows for the aggregation, like tumbling, sliding, time sliding, and things like that, and the size of the window. Again, in this demo, I am not going to demonstrate that, so I will just skip. And then finally, you can select the final destination of your data. As you saw, I configure a Postgres database, so here it will show that. But we also have support for, as I showed you, many different data stores, and also we support sending the data to a blockchain. All right, so here I'll select the Postgres database. I click next, and now the pipeline is ready to be saved, or you can also save it and deploy. So in this case, I am going to do save and deploy. And in this case, the data was saved and actually was deployed. So right now, the container was dynamically created using our Flogo tool and is deployed now in a Kubernetes cluster. So now every time I receive data, the data will run through this data pipeline and do whatever actions we have implemented. Another feature that we are coming very soon is that right now these containers are being deployed into the Kubernetes cluster. In the future, we are going also to provide an option to deploy this data pipeline to serverless in AWS. It will be deployed as a Lambda function. Okay, any questions so far? Or I'll just keep moving on. All right, so now that we have the data pipeline and the data is being sent to this, I want to go and visit some of the data, see how we can visualize actually the devices and the data. So I will go through all of the different features that we have here. So first thing is I'll go to the devices page. So in this page, you can select what grouping of devices you want to see, the gateway. So in this case, I want to see, let's say, these electric vehicle devices that I have running in Seattle. So here we can see that we have only one device. It's called a Versi Charge. Is a charger. And here we can see in real time a summary of the different data from the different sensors that we're receiving. So here we can see that the energy being consumed by this electric charge is 0, the voltage is 225, the current is 31, and actually it indicates that it's not charging, that the device is not charging, it's not connecting to a vehicle. So here also we can see a summary of all the instruments and a description. So if I click on, for example, on the status, I can see a more detailed information, like it will give me like what type of data the data is, what is the permission, what is the minimum value, maximum value. In this case, we don't have it, and the default value is power is available. Okay. And also we have a visualization of this data. This is a discrete type of data. It's not a numeric, but we still provide some visualization. So here at the bottom, we can see that when the device has been charging, when the device has been under reduced rate charge and things like that. Here we can see when the power was available and all that information. See, we can see that in real time it changed, and now it's displaying that the power is available, and you guys can see that these values will be changing as we receive data from the device. So here it has changed and it's ready to charge. Another feature, like for example, if I click the voltage, we see the details for that specific sensor, and also we can see a history of that device, that all the data we have received for that device. And at the bottom, we also have actually a streaming data that is coming in real time. As you guys can see, the data is moving, and we will receive, as new data is received, we will show the data. So in this case, as you guys can see, is a very good flow of data coming in. So let's go to another type of device. Now, before going to the other device where I want to show something different, let me go through and show you something else that we do here. Also, what we have here, what we call edge rules and also edge ML models. So these are allows you to configure rules and how to use data and run through models. Okay, so let's go to the edge rules. So in this case, we allow you to again select different devices from the different gateways that we have and create rules that you can interact with the devices. So for example, let's select this electric plant. And you guys can see at this time I don't have any rule configured. So let's create one rule. So let's create EdgeX. EdgeX demo. That's the rule name. I'll just put description demo. So on the conditions, we are able to select what device we want to configure this rule for. Okay, so here in this case, I just have one device, and then it select the metric. These are the different sensors. Here we can see all the different sensors that we have available. We are receiving data from that device. So let's select this production per minute. And also on the conditions, we can select different ways to configure the rules. So for example, we can select if the new value, for example, is greater than something, then we want to do some action, for example. So let's say if the value of this is greater than this. And also our rule engine maintains the state of the data that we have received. So we can configure, for example, a rule that says, compare the new value against the last value that we read. Or you can say, okay, I want to configure my rule to check the last value that we received, and if that was some greater or equal or whatever operation to some other value, and then trigger. So in this case, we are going to check for the new values that we are receiving from that device. And then we have right now, we are supporting two types of actions. So the first action is just send a notification. So let's say, and we are saying production, let's say prod 2 law, something like that. And then on the command, we can interact with other devices. Unfortunately, in this case, I just have one device, but again, you will be able to select what devices you have available in your configuration, and also select the different metrics. Like right now, if I select that device, it will show me all these other sensors that I could communicate with and send some command to act on that. So in this case, let's don't select the send command. So we'll just send a notification when we receive a reading that is greater than 20 from this sensor. Okay. So again, so we'll do our rule. As you guys can see, everything is dynamic. So right now I have my engine in the edge is not running. So when I got the rule and then select the rule and then deploy it, then the rule is dynamically deployed to the edge, and it will start receiving that data, and it will start acting accordingly to whatever we configure. So right now I'll do deploy, and the rule was deployed successfully, and now we should receive notifications shortly whenever we get these readings that are greater than 20. So for example, hopefully I get some values greater than that. I can go to my notifications window, and boom, here we have, as you guys can see, the source is a Flogger rule called EdgeX Demo. The device is the power plant, the product per minute was, the reading was 387. I intentionally put 20 because I know this reading was high so that the rule will trigger. And here we can see that the description that we provided, okay? Another feature that is very nice and I want to share with you is also the EdgeX, the Edge ML models. So here I have already pre-configured something so that we have some data that you guys can see. So here I have configured again for the power plant. You guys can see here I have an anomaly detection configuration. And in this case, I have selected again this device power plant. Again, if you have many devices, you will have the choice to select whatever device you want to apply that data to the model and get evaluation for the data. So here I selected again the metric. I am monitoring this product per minute, and here I have selected this anomaly detection model. Okay, so what this model is, it will get the data, we will send the data through the model, and the model will return a score telling me if there is an anomaly or not. Okay, so that is already running. I have deployed, and I will show you the results shortly. So let me go and show you that. If I go to my devices again and select the electric plant, we can see here, okay, so here's a real-time visualization of the last value that we received from the device. You guys can see the values changing. Again, you can click on the product per minute and see the details. So this measures the energy produced per minute. And also here are some of the information on the details on that sensor. So here we can see that this is a type flow 32, it's a read-only, minimum value is 50, the maximum is 500, and the default is 170. Okay, so here we can see a history of the values we have received here. So here we have a button that is will show us the anomaly detection values from the model. So we jump into a Spotfire dashboard, and here we can see here in the blue line are the values, actually the real values coming from the device. As you guys can see, I highlight that line. And the yellowish line is the values that was scored by the model. So we can see that the model is doing a pretty good job. It's pretty close. And at the bottom, we can see the difference between the values the value that was coming from the device against the value that was coming from the model. And we can see here in red, these results were marked as anomalies. You guys can see this peak here. So we can see here that the model detected correctly that there was some anomaly on that device. So what to do next with this? So we have, as Jesús mentioned, we have our data science product. Using a Spotfire, we can go deeper and try to detect what was the source cause of this anomaly. So if I go here to another dashboard, close this. So we can see here just not the recent data, but we can see a history of the data for this device. Here we can see again in blue is the original value that we have received this data from this device over time, and the yellow is what was coming from the model. If we select, let's select this little peak here that where it was anomalies, we can see at the bottom, we can see immediately it will mark the values that were coming with the anomaly. And now if I want to go deeper and use another type of models that will help us determine the root cause of the anomaly, we can go here and we can investigate not only the data that we're receiving for these sensors, but we are also here, we can see data that we have received from engineers at the plant and that log some information they have seen during that time of period. So here we can see that some engineers enter some complaints about faulty barometer pressure and things like that. And also here we can see, we run this data to a model and we can see the key driving factors of all the other sensors that are interacting with this production per minute. So we can see that in this case, there is a waste gas, 1 dP, and a barometer pressure sensors that are influencing a lot on the result of this anomaly. So based on the further analysis and running through a model, we can see that the faulty barometer pressure was actually the cause of the anomalies, and there is an advice coming from the model and is advising us to replace that sensor immediately. So as you guys can see, we have an end-to-end solution, starting the data being generated by the device, us capturing that data at the edge and then moving it to the cloud. In the cloud, we save the data.
Downloading this photo from iCloud Photos. Try again later.
Can you please mute your phone if you're not speaking?
Yeah, so I think I have some other things that the US will be familiar here, is like the device profiles. We can select all the device profiles like for the different things, and here we can show you all the different things, and you can edit and change it, and we will save it to the device profiles that are running on the edge. I think with that, I think I want to leave some time for questions, or if you guys have something specific that you guys would like me to show you here. As I said, I haven't included in this demo some of the other features that we provide with other Tibco components, but this is basically the base of everything we are doing with the EdgeX framework.
Marcelo, Jesús, this is phenomenal. Great work and a fantastic presentation. Thank you. So let me open it up to the floor. Are there questions? There were a couple of questions in the chat, but I'll first open up to the floor. Anybody have any questions you want to ask to the Tibco folks?
Yeah, I've got a question. This is Tony Espy. I'm a TSC member. And one of the things I wanted to know is, are you interacting at all with value descriptors, or are you instead just choosing to cache device profiles and use the device profiles to understand the data as it flows through the system?
The device profiles, we're using the device profiles.
Great, thank you.
A precursor of things to come. Hey, Tony. Thanks, Marcelo. Marcelo, we have a question from James Bush, who asked, are you using the EdgeX rules engine, which is Kuiper? I thought I saw Flogo there, so it looked like maybe you're
Yeah, it's the Tibco rule engine. It's open source. It's called Flogo Rules. It's available on GitHub, and that's the engine that we are using for the project.
Fantastic. And I do have a question here for Jesús from Sudeep. Sudeep asks, Jesús, if your project here, Project Deer, is that available for white labeling?
Yes, well, I mean, Tibco has a very large OEM ecosystem. So if it's, you know, if the idea would be to consider like an OEM approach, certainly, you know, that's something that we can take offline. The project itself, as I mentioned, right, is basically on GitHub, right? So you can, you know, anybody can download the project, and it's all based on open source, right? It's more when you start thinking of incorporating other Tibco products that then we'll have to have a conversation in terms of the licensing of those products.
And maybe just to follow up
I want to clarify one thing, that most of the components that we're using as the base for the project are based on Tibco Flogo, which is also open source. And Tibco Flogo is a user interface for creating code without coding, right? It's a UI kind of coding interface, and that is open source. So that's what we are using behind the scenes to generate all the engines and containers that are running behind the scenes.
So maybe a follow-up to that question for both of you, Marcelo and Jesús. I assume then Tibco's interest in this project, Project Air, is really, it's kind of a feeder to your other product set. Is that correct? Since this is open source, you're really looking to try and drive other back-end Tibco solutions.
Yes, I would say yes.
Yeah, I mean, I guess just to be fair, like a classic scenario for us is, you know, we come in, to these environments where there's already a lot going on, right? Like whether it's on the edge, on the enterprise, and then typically then there's gaps, right? Aside from just the IoT platform, there's other gaps on either side or both that we can fill out with Tibco-based products. So, but you know, the idea is really, you know, just to facilitate that connectivity right between the edge and the enterprise. That's the core premise.
Yes, and as Jesús mentioned in the introduction, Tibco has been doing this type of integrations for a long time. So what we're trying to accomplish here is to just make that integration easier and do it just once instead of creating many different solutions for each type of sensor like we have been doing for our clients. So we want to have something that is common, reusable, and easy to use.
Absolutely. Other questions from the field?
I have a question. This is Trevor Kahn from Dell. With regard to the ML models that you showed, I'm curious, is that, this is kind of a two-part question. The first part is that a separate process that hosts the model, which you are identifying through a device profile and tying it to a device service?
Yes, it is a different process that, like, for example, when we will have different types of devices and different types of data, so when we select the device, we will show what model is actually applicable for that type of device and data. So because like if this model might not be applicable for, like, say, if we receive an image, for example, right? So in the case of an image, we might have another model that detects images and things like that. So we will properly try to match and show to the user the right model to use.
Right, and so to EdgeX, it just looks like another device.
Yes.
Okay, so then the other question I have is, do you have any interaction, given this model that is making predictions about the range of data that's coming in, is that model receiving any of the readings that are coming from the real devices in order to fine tune its prediction throughout the day?
Well, no, the model just receives the data. The model was trained using our Tibco data analysis tools, right? So we collected data first and trained the model, and then once the model was trained, we deploy it as a container, and as data is received, we just run through the model. So it's no new training going on at that time. It's just the scoring.
All right, that answers my question right there. Thanks.
Marcelo, you showed at the beginning, you showed how the gateway was, or you said the gateway was empty, and you used Project Air to then push things down through Kubernetes down to that node. So once that's done, how are you provisioning the device then? Is configuration sent down with that provisioning as well?
No. The devices are not done that way. The devices are use EdgeX, right? The regular EdgeX framework. What I show creating the data pipelines, those are in the cloud,
Gotcha.
Right? Those are deployed at the cloud. Those are Flogo processes that are being created and put together to receive the data once the EdgeX framework sends to the cloud.
So in your particular instance, somebody would have to configure the devices to that gateway already using whatever means. Then you're posting down your elements to the gateway secondarily.
Yeah, right now the way we are doing on the edge, I mean, we are just enhancing, adding things to your Docker Compose, and we add all our containers there, and so they will get started along with all the EdgeX other components.
Gotcha.
We're just using the SDK to add new components to the edge.
Other questions from the field?
Jim, my name is Ike Allison. I'm representing the community. I'm just a little bit curious, in the implementation of EdgeX, which areas of competencies do you think that you actually may need in the future some assistance? Also regarding some of the companies that have been, contributing to EdgeX. I mean, EdgeX is quite substantial platform with the core services, DevOps, applications, security. Which areas of competencies do you think that actually you get substantial value and you may need some potential assistance in the days ahead of us?
Well, the main area that we interact with is the application SDK. I've been interacting with the applications team at EdgeX, and it's been very, very helpful. Any question I have, I get an immediate response, and that's what I like about EdgeX. Is a very nice community, very helpful. So that will be one of the areas. Another area that we are starting to work heavily is we want to be able to deploy these containers to the edge, actually dynamically, the way I show the way we deploy to the cloud. So we are looking into Project GIF and see ways that we can achieve that more dynamically. Because like right now, all the models and all the publishers of data have to be run ahead of time, right? They have to be pre-configured and running on the edge. We want to be able to deploy all of those components dynamically too, according to whatever the user configures on the user interface.
Marcelo, when you say you're using application services to get the data off, are you using app service configurable, or are you doing your own custom work with the SDK?
Custom work with the SDK.
Okay. And the reason for that is, are there certain things in the app service configurable that if they were there, you would use that, or is it just too complex of an export to really do with some sort of configurable service?
As I said, we are trying to be very dynamic. The configurable kind of is a little bit static. So we want to be able to stitch these processes together according to what the user wants. Like, and if they want to change dynamically, also they can add or remove like filters, or add or remove streaming components, rules, or any of the different things that you can work with the data. So that's why we are using the SDK directly, because we have a lot more freedom to do that. And as I said, we are hoping to be a lot more dynamic in the future, and not just in creating the processes, but also deploying them.
Other questions from the field? I'll ask another question here, Marcelo, with regard to maybe kind of a follow-on to Ike's question. With regard to the platform, are there any particular elements that you see? You mentioned a couple of places where you'd like to see some additions. You know, things like deployment and orchestration, things more configurable. Are there things in the platform you see today that you would additionally like to have added, or fixed, or changed? What are the sore points in EdgeX that you'd like to see?
Yeah, right now we haven't really got any real scenarios yet, but we are envisioning that we will have issues with, clients having all kind of sensors and protocols and formats. So we were looking also at the project what is called Flash. So we would like to see some kind of interaction between the two communities, because they have some support for some protocols that are very important in the manufacturing world. So that will be very helpful if there is more support for those kind of devices, and if there can be some interaction between the two communities.
Got it. So a fledged input into EdgeX.
Yes.
Other questions from out there amongst the community? Silence. We've stone cold impressed everybody out there.
One question. Is this deployed anywhere?
What was the question?
If it has been deployed anywhere, like if any customer is running in production with Project A? Not yet. The project was actually recently released. We had it in beta running all the way until May this year, and then in May we released the project. So through the last 3 months, we've been engaged in various POCs, and hopefully we'll have the first implementation soon.
And Jesus, is this something that the Tibco verticals come to you in Tibco Labs and say, we have this use case and customer, and then that's how you interact and deploy? Or
Yes, you know, and that's actually the case for not just Project Air, but pretty much any project under the Tibco Labs umbrella. Like if you look at Tibco's portfolio, there's no Tibco IoT product per se. So, you know, when there's IoT scenarios, right, Project Air is basically the way to have that conversation with our customers and partners. So yeah, we get invited to different cycles from the vertical team, from our field folks, and why not to partners, you know, from the channel as well.
Very good. Any other questions? And we did have one question from Ken asking about the source code on GitHub, but I think that was answered by Jesús there on the chat window as well. Ken, if that doesn't get you what you need, let us know. If there are no other questions, I'll pause just a second to see if there are any other questions. If not, it is a real pleasure to have you guys present. Jesús, Marcelo, well done demonstration, well done presentation. We really appreciate it. This kind of information is just absolutely gold to the project, understanding how people are using it and what are some of the shortcomings and what are some of the benefits of using EdgeX. So we deeply appreciate it. And with that, folks, we'll let you go. Again, thanks to everybody for showing up, and continue to monitor the Slack channel. We'll try and get you some additional adopter series presentations coming up in the near future. Thanks, Marcelo. Thanks, Jesús.
Thank you so much.
Thanks, guys.
Thank you.
Have a good day. Bye-bye.